guys, today we are going to go through Golang basics. So what is Go? Go is an open source programming language. It's a statically typed language. It's a compiled language, and Go is extensively used in any modern applications, any server-side applications, machine applications. So we are using Golang extensively currently. It's a very modern programming language that handles many machine uses cases, how like concurrency patterns, parallel programming. So Go handles everything very easily. So let's see what Go is. So we can go to official Golang documentation to explore more about Go. So just like I mentioned, Go is a simple, reliable, efficient language to make programs. It's completely open source. So let's build a sample hello world program with Go and start from there. So first I'm going to write a package. So every Golang piece of code is going to be written in under a specific package. So for our main program, which is going to be the entry point to any Golang application, I'm going to give a package name called main. So this is going to the entry point package, and I'm going to define the package, the main program, that should be with the name main, and this is a main function, that will be the entry point to this program. Now let's do print hello world. So what do we call? We can use a predefined package called fmt. This coming with the built-in libraries of Go. We can use that to print hello world. So the function we can use is println, and we can put hello world. So we can see that an extra line is added saying import fmt. So this is done by VS Code extension, Golang extension, which automatically adds the mixed import while we save the file. So we have a file. Now let's run the program. So we have a hello world printed in the standard output. So like I mentioned, Go is actually a statically typed language, so it has to compile first, and after the compilation the program is starting to execute, right? So what if we need to see the binary? So we have a command called go build main.go that will actually create this binary main. We can call that also instead of go run main.go. We can invoke that binary to run our application. So you see we can run the program like this also. As we mentioned, Go, this current program is written in a main program, but when we write actual code like building very big applications, we cannot have everything under a single package. That will anyway going to affect readability. So what we do in Go is we will break code into chunks of small packages and bind it together. So how can we do that? Actually we can use, so in Go there is a way we can bundle different packages together, that is actually via modules. So in Go we have a command like go mode init, and let's put a module name like example. That will give us, so that will allow us to write bundle the packages we can define in the same folder. So let's create another package here. Let's name it common, and let's add a new file like utils. So I'm just simply going to create a new package and add a function to print time. That will just print current time. So what I'm planning to do is I'm going to use this function inside main.go. So let's import the package. So my module name is example, and I'm going to call the package common under my main package. How can I do is I can just pass the module name, then the package name, that is common, and we are just going to comment on the hello world. So we have multiple packages to import. We can put it under the opening bracket, and let's call the function we have written in our common package, that is print time. So what happened? It's not, so just remove fmt because we are no longer using that. When we save that, it's automatically deleting the common. Let's see why is it. Let's try to build the application. Why? So it's actually, we are not saying it's not importing. Let's import that. And see, there is an issue. Go print time is not exported by the package common. So the issue is we should, in order to expose a function or variable outside a package, we should start the function with a capital letter. So now we have print time. This is actually exported function, and we can use that in the main program. Let's import the package now. Now while saving, it is not getting removed, so it's a valid case. So yeah, it is working. Let's try to run the program. So we have the current time printed out here. So that's how we have different packages and bundled together to use inside an application. Okay, let's talk more about functions. In Go, we can define a function like starting with the keyword func, and we can start with the function name. Let's simply create a function called sum that will actually help us to find the sum of two numbers. So my first argument is going to be a variable with integer type. Second is also an integer, and I'm expecting an integer as return type. So output is simply x plus y. It will simply return the sum. So let's pass some values. Let's clear it from here. Let's give some value to x, 2, 3, and y equal to 2. Let's try to print the sum. fmd.println sum of x comma y. So we are defining x 3, y is 2, then calling the printing the output of the function sum. Let's see what happens. Okay, we are getting 5. So you can say the function is working. So in this case, both the arguments are integer. So we can actually remove this int. So essentially x and y will be considered as integer, and we can return the output back. So this will also work. Same result. Now let's see. In Go, we can have more than one return type, unlike some other languages. So we can have the same function to return sum and average. So let's pass x and y, and say we want to we are expecting also average of these numbers. So let's return float 32 value, and the first one will be a sum, and also I'm going to return x plus y by 2. So it is actually throwing some error here because sum is currently not defined. Let's put the variable, the new variable. Okay, we have some issue here, like we are returning a float 32 value but we are passing integer. So let's convert the value to float 32 and let's run the program. So here we got sum, we are printing sum, and also average as a second return type. We are also printing average also in this case. Okay, now we can one of the form, how can we write this kind of function is like this. So let's have the same function like v2, and we can actually declare variables, declare the return types in the initialization itself. And instead of doing like this, let's do it some other way. Average equal to float of x plus y and sum equal to x plus y. And now we can just simply put return. So let's also see print that sum and average v2. Let's print this. We have the same result. So we don't have to pass the actual variables here. We can, since it's already sum defined. So this kind of return is called named returns. We can define the return types in the initialization itself, and we can simply call return without any arguments passing. Okay, now that's something. One of the interesting thing we can do here is actually we can actually do something interesting stuff. So we can have a function called swap that accepts x comma y integer, and also we can have a return type in comma int. This is going to be the return. After the return, to let's see the value. For the same, we can do like this, simply do like this. Since we can return multiple values, we can do this. So let's print x comma y, and also let's do swap x comma y equal to swap y comma x. Let's print xy again. If we do this, let's comment out the other stuff. We see we can do simple swap like this. Just return, because we can actually return two or more arguments in the same function. Okay, let's talk about Golang variables. So let's clear everything. Okay, everything is cleared. So we can have global variables and variables inside scope to specific variable, specific functions. Okay, so we can define a variable of a specific type. Like for example, let's define a variable of type integer. My variable name is x and my type is integer. We can print the value of x, fmt.println x, which is to print x. We have the value 0 because no value is initialized here. So if you look at it, this is the default value of x. So default value of x integer will be 0. Let's try some other examples also. Y bool var insert string. Let's print them all. So when we do that, we get 0, false, and an empty string that we cannot see because it is empty. So these are the default values for every Golang types. So that will be printed here. So we can actually define variables at the time of a declaration. Let's do that. Let's pass some value ABC for the string, true for y, 2 for x. Let's print that also. Okay, we have x, a, y, c printed here. So we can pass values at the time of initialization itself. Now one other way to do the same thing is, can define x equal to 2, y equal to true, z equal to apps. And if you just do go run main.go, it is the same thing. So we are not using the keyword variable to define a variable. Instead, we are using a colon and equal to. Actually, what happens here is, based on the type of the value we are passing, it actually the variable takes the type, infers the type from the value we are passing. Like here, it is a number, so it will be integer. Here we are passing true, so it's going to be a boolean, and since you are passing a true string here, it will be of type string. One thing we can actually do is we can actually print the type of this variables using a package called type reflect dot type of. Yeah, this is the package and this is a function. Let's print the type of all these functions. Y. So let's do that. So we can see type of 2 is int, true is bool, and the apps is string. So how this kind of definitions we call short variable declarations. We don't have to actually explicitly pass the type of the variable or specify var, and just put colon and it will take the type from here. So most common Golang types are boolean, string, int, and 8, int 16, 32, and 64, and also uint till 64. There's byte, there is rune, that is in 32, and also there is also float 32 and float 64. So okay, actually we can, so we define a variable of type int 32 var num of int 32, and let's say we are passing a value called 4, and if we want to just, so if we want to assign to a variable of type x, we cannot simply do x equal to num, and the typecasting doesn't work that way in Go. So for that we have to explicitly specify the type of the target variable. We have to specify it like this, and then we can just print that. So this is the way we do type conversions in Go. Just to Go, we can see the value of x is printed here. Okay, if we don't do typecast, type conversion, and do this, it will end up in an error like cannot use num in 32, so type in an assignment. So keep the same in mind. Okay, also we can have constant variables, so we can also define constant variables in Go. Let's comment all these things out. Let's define a const variable name, string type, and let's pass some value ABC. Let's print that. Okay, let's see if this is okay till now. Yeah, we can print ABC. Let's print that again, and between let's try to pass in the value CD. Yes, DD. Okay, so we have an error. cannot assign name constant since it's constant, so keep that in mind. It's constant, we cannot change the value. So that's also something to keep in mind. Also, okay, we can pass values also in this way. Let's comment that out. Let's y z colon equal to named short. We are going to go for short variable declaration, and we can pass a value to true and abc, and also just copy this, and this should work here also. So this is also a way we can define variables in Go. Loops in Golang. So we can use a for loop keyword for looping in Golang. So let's have some condition. We can just like how we see in C and other languages. We can have a for loop like this. Let's put some condition like this, and then incrementing also after every loop. Let's print the variable I. So it's a simple program that will actually go run. It will print till 9 from 0 to till 10. Okay, let's put that again. That will print till 10. Okay. So with for loops we can print these numbers, increment numbers like this, and also actually these are not mandatory like the initialization. We don't have to do it here. We can do it outside also, and we can achieve the same thing here. And also the incrementation also we can do inside the program also. This is also not mandatory, so we can do it this way also. The mandatory main thing we should have a condition within the for loop for a for. Okay, so when we see here, we can see that this actually acts like a while, right? So it runs until this condition is met. So instead of while, we can use for in Golang to implement how we see in while. And also if we just don't have any condition, we can run the loop like infinity. That will it's going to be infinite loop. And if you want to break any for loop, say if I greater than 10 or equal to I greater than 10, I want to break the loop, so I can do that. See, we have printed till 11. We have printed till 11, and we just break out of the loop. So that's also possible. Okay, now let's talk about if conditional statements. So let's take an example of odd or even. So I'm just going to pass a function, pass a variable, and okay, it's equal to 2, and I'm going to check whether this number is odd or even. So it's equal if x mod 2 equal to 0, if empty dot println, let's say it's all right. So okay, let's see that it says even. So this is single if case, if condition. So if we're putting 3, we don't have anything, so let's handle that also. Let's handle the other case also. Println odd. So it's odd, so let's see for another input, let's say 4, let's see it's even. So this is how if else condition works in Golang. Another way also, let's say even equal to x mod 2 equal to 0, and if even equal to true, even, then just do this. Same thing, right? So this is also a way we can use if in Go. So this also works. So we can just have some statement execute in the if itself and not outside. So this is the way we can use. This is useful in sometimes. Okay, let's go to some other branching method. We can use that earlier. So we earlier saw that reflect.type of. So I'm going to put x equal to 2 and switch and have a switch, and I'm going to have function reflect dot type of x is reflect dot int let's say a int. Let's handle a few more other cases. Float 64 string, and this, let's run the program. So okay, so we will pass x equal to, so it's an int. Let's pass 1 to a string. So it's a string, so this works. Also we can have a default condition also. Default let's put a boolean value. So it's not inside the case statement, it's a different type. So that's how switch works in Go. Okay, also there is we can have a switch without any condition. So there's without any condition, let's remove that. Then in this case, okay, putting some x equal to 2 and so in this case, inside case, instead of having some values we can compare against, we're actually going to have condition. Fix mod 2 equal to 0. We want to say it's even. And I'm also going to have a default case. It's a odd. See what's happening. So it's an even. So you can have such cases like this also. If we put 3, it says it's an odd.
It called defer. What does actually defer do?
Defer is used to defer the execution of a statement. So let's say if you want to execute something at the end of any inside a function, if you want to execute something at the end, when the return happens, we put a keyword called defer and the function that we want to execute at the last. So let's
let's look into a practical example. Let's print some number. Let's print 1, and then let's print fmd.println 2, and also let's print fmd.println 3 and 4. So ideally this program should print 1, then we should when the defer is reached, this will push to a stack. It will this is going to be a deferred statement, so this will execute at the end of when the return actually happens. So this will push to the stack, and then we should print 3, and then finally we should print println to the defer again to the stack. So once this return is, then nothing more to execute. We will pick a default statement from the stack. So since this is the last one we push, this will be popped from the stack first, and this will be executed. Then this will be popped out of the stack, and this will be executed. Let's execute, run the program and see what happens. So if you see 1 executed, then push to stack, then 3 executed, then this push to stack, then again since it's a return, there's nothing more to execute. It will start picking up default statements on the stack. So it is 4 will print first, then 2 again will pick it from stack. That's also printed. So that's how defer works. Pointers are, as we know, pointers are actually address locations of a variable. So let's define how to define a pointer variable. We can have a pointer variable p for a integer type. So let's put the value equal to, let's define the variable equal to 2, and let's try to print that variable a. And also what I'm going to do is I will assign value of pointer p to the address of a, and I'm going to print this a. So yeah, we can print p here. Let's run the program. So as we can see, we just print a, then also we printed p, which is a pointer to the variable a, and we have that here. So how to update value of a variable using its pointer. So we can update value of variable a actually using, so let's like this. And if you want to print let's print p and a once this is done. So let's print that. So we so after that actually we assign change the value of pointer p. Pointer p is actually the address location of a, and using the syntax we can actually update a value of a. So we did that, and we just first print p pointer, so that does not change because it's the same address location, and then we printed a, and the current value is 3. So that's how we use pointers in Go. So if you want to store some variable, so we want to have a complex object like a user, so it should have name fields like name, age, and any other fields we want. So struct allows us to do that in Golang, right? And like any other language. So how to define a struct? Struct is defined. Let's define a struct like user, and first we should put the keyword type and the structure name and the keyword struct, and let's add the variables. So I'm going to have some names for the user, and I'm going to have some age, value for age. So let's initialize a user. So let's put the name u1, and if we just do and name, and let's put Adam, and let's put age 1, and let's print the user. So this is a struct literal. We are actually assigning the values and current just printing the same. So let's run the program. You can see we have got this printed, Adam and 1. can also, without passing the field names, or even though it is not advisable, we can do this like do it like this also. So in the order of how it is defined in the struct, we can do like this also. So this is also the same thing. One more way. Okay, now we can just see the values only. So if we just, instead of doing a secondary print, we can actually do a printf and this push hash v. So it's actually v is for actually printing out the value. When we put hash also, it will, instead of values, it will also specify the fields also. So let's print u1 like this. Actually we can get the type, package, the type and field and value. So we can get it like this. But yeah, that's how it is. Also we can have pointers to a struct variable also. So just we can have a u1p, we can pass the value of u, we can have just pass u, and we can, let's print out the pointers, what is inside u1p. Can print u1p, and also we can pass the value. So let's run that. Okay, it's u1. So when we are using struct, it is going to print it like this. So if you want to see the actual pointer, what we can do is we can do a printf, and instead of passing v value, we can specify %p, and we will get the actual address. So let's put /n. So here we can see we got the address. If we just pass the pointer %p, then we will get the pointer to the struct. And go. So we can define an array like this, var, and I'm going to put the array's name as, variable name as a, and I'm going to specify the size, like I'm going to have an array of size 5, and the type. So let's try to assign some values to it, equal to 1, 2, 3, 5, and I'm going to print the array. Missing it here. Okay, we have to again put the size here since it's an array. Okay, let's run that. So we have got this array. So this is how we define an array in Go. Instead of doing this, we can actually, if we just put a colon, this will also work. This is also the same thing. And now let's talk about slices. Slices is actually implemented on top of array in Go. Slices have some other advantages compared to array, like increasing the capacity, increasing the length of the array. It is done automatically inside slice. So the difference is, this is an array. We can define a slice like this. We don't have to put the size. We don't have to explicitly put size here. We can just let's put it to some other variable b. Let's run this. So if you see, everything is same. When you print it is the same. There is no difference. Actually, slice is actually just like I mentioned, it is implemented on top of array. So and with some added features. One of the thing we can do with slice is we can actually slice the slice. So we can actually divide the slice by specifying the starting and end of the sub array we want. So like if you want to slice B, I can do that. Let's do something. fmt dot println B of, if you want to ignore the first element, and if you want to just print till the fifth element, let's try to do that. Actually we can get from first elements, ignore the zeroth element, we can print from first element till fifth element. This is the fourth element, fifth element is actually not here, so if we just put, instead of 5, if we put 6, we will actually get an error because 6 is not there. So the current slice only having a capacity of 5, because we are defining like 5 only, so there's no capacity 5, so it will throw an error. So it's important that we should, when we slice a slice, we should specify the proper indexes. One thing we can do, if we don't put the end position of the slice, if we do this, it will work exactly the same way. So it will go till the length. That is how it's going to happen. We don't put anything in front, it will print the exactly same thing. If we just put a limit here, let's say if we put 2 at the end position, we will get it from 1 to 2. So it will start from 0 till 2, till second element. 0th and first element will be present in the result. So that's how we can slice a slice. So for a slice, we can actually have a print the capacity. So let's try that. Let's print the length of B and also capacity of P. If we just do that, we know that the length is 5 and capacity is also 5 for this element. Let's try another. So there is a keyword called append that actually allows us to append a variable at the end of the slice. So let's update B, append B with, say this instance I'm going to put a 6 at the end, and I'm going to print the element, print the capacity and length. If you see the array, okay, let me print the slice also. We have the new element inserted and the length is 6, but the capacity is now 10 instead of 5. So what Go does in backend, it's actually double the size of, double the capacity of the slice, so that it doesn't have to, so underlying it's array, right? So it doesn't have to increase the size of the array for the next append also. So if we just add one more append here, if we do one more append like 7, if we do that, the capacity is going to be the same 10, but the length is incremented. So this doesn't have to do this changing of array. So we have to actually make a extend array, right? So it's a costly operation. So we do like this way. So this is how we can append the element to end of the array. Also we can create a slice with a dynamic array. So if we know what is going to be the size of the slice, what is going to be expected length of elements in the slice, we can actually create a slice with the specifying the capacity. So let's create another int slice, the capacity of 100. So and let's print the array slice a, then len of a, then also I'm going to print capacity of a. So let's print that. So if you see that it has an element of 100, so default values are added to all the elements, and there is also, it's actually an array, right? If you see, this is actually an array and the length is 100 and also capacity is 100. So this way we actually can access. So if we just we can actually use indexing for this kind of slice. If you see, we can put values like this, of 1 equal to 2, let's put like that, and we can actually access these elements like this. If we don't print a dot 1. Now it is possible. So we just print this. We can see f1 is equal to 2. So this is also something that will work with slice. Also we can actually make multi-dimensional slices and arrays. So let's show one of that. So I can actually make a 2D array, 2D slice, and array of 0 can be another array, slice of int. Let's try to run that. Okay, let's print the slice. See, this also works. So this is something we can do. We can go n-dimensional array with slices and arrays in Golang. For Golang, it is actually a range. So how can we, when and why is range used? So range can be used to range over a array. So let's take an example of, let's create a slice, and I'm going to put 1, 2, 3, 4, 5, 6. Okay. And I'm going to range. So I just want to print out all the elements in this array. What I'm going to do is, so I can have a index, variable for index and for value. I can just range through this array slice, and I can just print the values. See, we can see the index and the value at the index. So say if we doesn't want index, so if we does not want the index of this slice, we can actually remove that. We can just ignore that index like this. So if we just do this, this will also work. If we don't want the index. This works the other way also. If you doesn't want the values, we can just ignore the completely, and if we can just print the indexes only. That's it. So this also works. These are possible with range keyword. Range also works on top of map also. So let's talk about map. So I can have map. Map is actually a key value pair. So first we have to define a map. Make map of. Let's see. Put in key as string, and also value as also string. Let's use other variable b. So b is a variable name for our map, and I'm going to put some default values. So these are our key value pairs. So what is the issue here? Okay, this missed that. Okay, now we have this map. We have actually added some values here. Let's try to print the map. So we got name and age in that map. What we can do is we can actually range through this map for key value, range over the map b, and we can actually print, if we run println k key, k for key, then v for value. Let's put some differentiator. So see, we can print it like that. So this is also possible with the range keyword in Golang. Okay, on top of that, to a map, we can actually add new elements like this. So we can actually add a new key value pairs. Let's add dob, and let's add a string like 12, 1, 111. Let's print a DOB like that and go and main.go. That will actually. Let's print that map. Let's do that before the printing here. So we have that also inside that keyword inside the map. Actually, we can remove the. We can actually remove if you do not want some keys. We can actually remove that, like, and delete. We have to pass the map's name B and also which is the key we want to delete. So I just want to delete the DOB from here. So I'll do that, and I just want to print that to ensure the same. So if I do that, you can see actually I have added that DOB, then I removed. So you can see that here. Specific value, also we can access a specific value of a specific key. So we'll try to do that. Ln p of, I just need the name of the guy, so I'm just going to do that so I can get the name here. Functions are actually considered as values, so we can initialize variables and assign functions to it. So let's try that. I'm going to have a function like printfn is going to be my function, and I'm actually going to assign a function to the same. So I'm going to actually pass a string as input, and what it will do is if this print the function, print the string. Okay. So this is what it's doing. So let's use the function println, and it is expecting actually a value. So I'm just going to put abc. So we can actually print. So we actually assigned a value function as a value to print function, and just invoke the function like that. Let's see what will happen if we print the function. Print func. So if we do that, we'll actually get a pointer. Yeah, that's what we will get. Okay, now in Go there is nothing like class. So how we can achieve something similar to class in Go? So we can actually have structs. So we can actually define structs, like let's define a struct like user and have some field string, and let's print age int. And actually we can have functions over this structs. This is actually called methods. So when we write a function over a type, we can call it method. So I'm going to have a method for the type user. It's going to print name is going to be the function for that user. So we're actually going to do name of name. Similarly, I'm going to have another function to just print this age that will actually print the age of this guy. So let's try to define that. A equal to user and name. For simplicity, I'm just going to put like this only. Say user. So if you want to, we can do this, right? You can do u dot print name. That will actually print the user's name. Go run. That is going to print the user's name like this. So this is something as close we have with the class. We can use this one. Also, in case there is a need, we need to update any alter or mutate the values in field, mutate the values of a struct. Okay, instead of passing struct, we can actually pass the pointer, the struct, and here, like if you want to have an extra function like func. So in this case, we don't want to actually pass it to the pointer because we are just doing a print. Can have a function like func change name. Since it's a method, we should pass the type change name, and I'm going to pass a string, and I'm going to set view date name equal to a. I'm going to put it name equal to a. So let's try that out. View dot change name to able, and you wrote print name. So you can see the name has changed. So we have altered the name of the user like this. So we can also have methods with pointers. There are interfaces. Interface is nothing but a set of method signature. So actually we can say instead of value of an interface can be any type that has implemented the methods that is specified in the interface. So we can actually try to define an interface. Let's put person interface, and I'm going to add two functions. I'm just going to remove this one. I'm going to add the exactly same functions we see here. Print name, and that's going to not returning anything, and also print age, that's also not returning anything. So we can actually define a type of person. Let's say p is of a variable person, so it's actually point to the interface. So and we can actually assign p equal to user, and let's put some value Adam 1, and I'm going to just call p dot print age, also p dot print name. So if you see that user's type is struct user, and p is actually of type person. So since user implements these two methods, print name and print age, with exact same signature, we can actually pass for the value of p, it's a person interface, can pass the struct instead. So this is how we can use interfaces. So interfaces are very useful while we writing test, so that we can actually pass mock functions while writing test for different layers. So that is actually very useful there. So let's print this. You can see this works without any error. So that is what interface is. Also in Go we can have empty interfaces, like we can define variables like var, let's have key, let's have something called key, and an interface it is having nothing, right? It doesn't have any type, it's just empty interface, and we can actually put value, any value, like so this will work. So you can pass any type of value to interface, empty interface. So this is useful in that way. So if you just put 1, it works, and if I just put key equal to 2, this also works. So it was assigned integer first, then it is a good into this string. This both works. So this is very useful if you just consider just to from the dot println, we are actually passing a set of an array of interface, right? So it's we can pass any type of value without doesn't have any strict type. We have to pass println, and we can pass anything and it will print. So these kind of functions are implemented using this feature, like empty interfaces. So if we do not pass any put any value to an interface, what we will get is we just print that key with initializing, it will be nil. This is the default value for an empty interface. Okay, now if we want to copy the value of an empty interface to a specific type. Say currently I'm actually having key equal to 1 to the string. If I want to, instead of key, it's still an empty interface, if I want to store it to some actual string variable, what I can do is I can do key dot, can say string type, I can specify string, and I can vary a key string. So I'm just going to put in a key string variable, and I can actually print that. So this is possible, so this will work. So this is something we should keep in mind. So these are things possible. Conversion is actually possible, but if we just put int here, let's see what happens. So that actually resulted in a panic. So we cannot do this conversion because it is a string when it's not in, so that won't work. So this is something to keep in mind. One way to handle that this thing is we can actually, instead of, so this will result in a panic, right? So avoid this thing, we can actually do, what we can actually do is we can put variable OK. If OK, we can actually print key string. Let's see how this thing works. So actually, okay, let's put some identifier. So this is not actually printing, right? So because now this is not resulting in a panic, but now it's not printing. What happens is it will check whether this conversion was is actually a success. This is a type assertion. If the type assertion success, it will this will be true. If it is a failure, this will be a false. So if it's a false case, we don't have to print that because it will end up in error. So this is actually possible via this checking. Type called error to handle errors. So let's put some number to variable a, and if we want to, this is what we want to do is we want to pass some, convert the string to a number. So what I'll do, I'll use a built-in function called I2. So convert to, ask it to integer, so to I, and I'm going to pass value of a, and I'm going to get back num and also an error. So if there is any error value will not be, it will be non-nil. So if error not equal to nil, that is there is a value with to error, we will panic. We won't continue further execution. If or there's no error, we will just print the value of number. So let's see how this thing works. So now in this case it worked. Let's try to put some different value. So 123C. Let's try to convert this A. In this case there was an error, panic. So we can be passing errors, so we managed in that. So in this case we are actually handling error. So we can also have our own. We can create our own errors. Like we can use the println and the errors dot new, and I can pass my own error. Can't parse. Let's put a. Okay, let's put fm.sprint. So this is totally possible. We can create our own errors. So let's actually put that to a variable. And we can print an error. In this case it doesn't need to pass, so we can pass. So we create our own errors and it is for printing. So that's what type error is for. about Go routines in Go. So Go routines are actually lightweight thread managed by the Go runtime. Actually, Go routines are actually allow us to do parallel programming in the sense that it can spawn. There will be main Go routine running. That is our main program. And also, if you want to branch out a thread, lightweight thread, you can use Go, and that will run parallelly with the main application. So let's run a Go routine. See an example for this. So I am having a function to print num that will take a number as input, and let's variable equal to and print num a. So let's run the program. It is a very simple program that will print 2. What happened? Okay, we missed the print part. Okay, now it's perfect. We have the print right here. So if we just put a print here, we will do that. Go routine just got exited because main program is running and this Go routine was another thread. So this thread main Go routine has got completed, and the other thread didn't got time to complete. So let's do a time dot sleep here. Let's put a sleep for 1 second and see how it goes. So now we have we print 2 because in the main Go routine didn't finish. It did wait for the Go routine to complete execution, and it printed value of a, and since the sleep time was over, it's just executed the application. So that's what happened right now. Another example, let's print a word. So print 5 times. So I'm going to put a value string and in a for loop. We are printing it the value of a 5 times, and I'm also adding a sleep of, let's say, 100 time dot millisecond, and I'm going to print call this function inside this one. Print 5 times. I'm going to say foo, and I'm going to print 5 times per. Let's see what will happen. So we printed, you see that we printed on the random order. We check it closely, there is no specific order in the print. So because they are different threads, this one will work on the Golang main routine, and this will run on the separate Go routine. So that is why we are having this difference in result, because they are different threads printing the same. Channels now. So Golang channels are used for communication between multiple Go routines. So when different lateral threads are going on, we don't have any control over the threads. So Golang channels are used for the same. So we can actually define a channel like channel, and we can use the keyword make, and also pass the type of the channel. Let's put the channel of type integer now. Okay, now let's actually have a Go routine. Let's define a Go routine that will print 5 numbers. it will print 0 to 4, and I'm going to pass this channel, so that channel of chan integer in type, and when the 5 numbers are printed, actually channel will receive some value. Can put say 1 to this channel, and let's call this go routine, go print nums and the channel. So let's see how what will happen. So it actually started the main program go routine and passed the channel, but did most probably the printed all this thing, but it's happened after the main go routine end, so we are not able to see the result. So if we want to see that, actually we are passing these channels, right? Channel, once this is complete, we are pushing something to channel. So what we can do is we can wait to get some input from this channel. So if we do this, once the go routine is invoked, it will wait for a output, some value to be sent to this channel. So it will wait for the channel to complete. Let's see what will happen right now. Now we can see this numbers printed, and in the main go routine we are waiting for the channel to give some input. So actually we got a signal via this channel, the main go routine, saying that this numbers are all printed, so you can stop the execution. So to that it just stops the execution. So sometimes we can actually close the channel. So once the need for the channel is complete, we can actually close the channel. So this is actually possible in Go. Okay, now let's have a different function that will explain how we can use channels for communication between different Go routines. So let's have a Go routine that will actually push numbers to some channel, and the print will happen in some other channels. Let's try that out. So I'm going to put values of I to this channel, and in another Go routine, this doesn't need to be another Go routine, so I'm going to define another function, print nums. I'm going to rename this one to pass nums. That will actually pass the numbers to this channel. Print nums will listen on the channel and print whatever we get in the channel. It will just print that. So let's define that. So how can we get value from channel like this way? This way we can get values from the channel, or we can use this one. Let's show you. We can use for and value num, that actually we can get from channel. So whenever we push some values as channel, we can get it like this way. Actually we have to put the keyword range. Do this way, we can actually get the values via this channel here. So I'm going to do print here. Num, and I'm just going to delete this. But once all these are complete, we can close this channel. So all the numbers are sent to this channel. We can actually close this channel, and instead of closing in the main program, we can close the channel here. So let's do that. So pass nums will be we are going to be go routine, and print nums going to be the one who's printing. Let's run the program. If we see that what happened is pass nums is started, and it will wait for the pushing it will push numbers to this channel, and it will in the print nums, it's part of main go routine, it will actually listen to the channel and getting values from here. So when all these 5 numbers are put into this channel, when this is done, we're actually closing this channel. Since we are closing this channel here, and also we are using range here, this condition will be true till the channel is not closed, so the channel is active. So once we do this, once all the 5 numbers are pushed to the channel, this channel will be closed, and this will be condition will be false, and it will come out of the loop, and the application will end in the main program. So this is the way we can, this some of the examples how we use go routines in in our applications. Let's see some other example. I'm going to have a global variable var num int, and I'm going to have a function that will increment the value of the number. So one inc, what it will do is it will do num increment num. So I'm going to do num. I'm not using channels here. For equal to 0, I less than 1000. So I'm going to actually increment the same, and I'm going to finally, when all this are complete, I'm just going to print the num, value of num. So we should get 1000, right? So if I'm going to put a go with the same, let's see. I got 954. What happened? So if I'm again running, now it's 906. So what is actually happening? So the thing happening is all of them are multiple threads running, and each of them will be incrementing at the same time. So only one increment will be ineffective. It both happens in the same time. So how can we handle this? So what we can do is, Golang provides a package called sync. Actually, we have to make sure that num is updated only. Num is only updated by single go routine at a single time, and we are incrementing at this function. So what we can do is we can again define a global mutex for mutually exclusive update. So just putting mu sync dot mutex, and I'm going to use lock to enable mutual exclusion, and to unlock one that update is completed by a single go routine. Let's see that. Oh, still there is issue. What happened? 100. So what's happening is, so we are not waiting for all the go routines to complete. So let's time dot sleep, so that we give enough time for those go routines to complete. Okay, now we are giving enough time for all the go routines to complete. Okay, now all the routines complete, and we got the value 1000. So let's try and remove the same. If we don't have this doc, it will be still different value. Okay, so that's what channels, go routines, and log is supposed to do. That's how we achieve concurrency and mutual exclusion when we're using go routines. Okay. Okay. So that sums up it. So let me know if you like this video, and if you want similar videos, let me know. I'll be posting more videos related to Golang. So if you have any interesting topics that you would like for me to share with you, let me know. That I will do. Please subscribe if you like what you saw, and if you're interesting, click on the bell icon. Thank you guys. See you in the next video.